Hi everyone, welcome back to Z Physics. Today we are going to be carrying on with our multiple choice practice. In particular, we're going to be looking at OCR's 2017 Breadth in Physics multiple choice questions. So let's get started. Question number 1. Which statement is not correct about an electromagnetic wave? It can be diffracted. Well, this is definitely correct. So EM waves can be diffracted. They can also be polarized. That's how 3D glasses work. They are not longitudinal waves though. They are definitely transverse waves, and also they travel through a vacuum. So in this case, the incorrect answer is C. Question 2. We have a narrow beam of light and air is directed to the surface of a glass prism, which is the correct diagram for the light refracted by the prism. Okay, so first of all, when the light enters, it should bend towards the normal, and the normal is a line at 90 degrees, so it's going to be about there somewhere, so that this angle here is 90 degrees. Now notice that in this case this light ray bends away from the normal in case A, so it can't be this one. In case B, it also bends away from the normal. Now in case C, it is bending towards the normal over here, so as soon as it enters the prism, it bends towards the normal, which is correct, and as it leaves, it bends away from the normal because it is leaving in a lower refractive index. So C has got to be correct. Question 3. The force against extension X graphs of 4 different wires A, B, C, and D up to their breaking points are shown below. Which wire has the greatest work done on it before it breaks? Now, in an F against X graph, work done, I'm just going to write this over here, is equal to the area underneath the graph. So the area under the graph. So all we need to do is really just compare areas for the 4 different possibilities. Now, even judging by eye, we can see that C and D are not going to be the correct answers. The reason for that is because the area is clearly smaller. Now, A, that is probably going to have a smaller area, but let's just be sure. So A is going to have, it has 2 squares by 6 squares, so the area of A will be half base times height. It's going to be a half times 2 times 6, which is just equal to 6. We don't really know what the units are. For B though, it's going to be 1, 2, 3, 4, and then 4 across, so that's going to be 16. So that here was the area of A. The area for B is going to be half times the base, which is 4 times 4, and if we multiply those out, we're going to see that this is going to have a greater area. So B will definitely be the correct answer because it has the greatest area. Question 4. An object experiences 2 forces, 3 and 4 newtons in the same plane. We don't know the direction of the forces. What is the magnitude of the resultant force acting on the object? Now there are several different scenarios. For instance, let's say that this over here was the object. Because we don't know the actual directions, some of the extremes are if they're acting in the opposite directions. For instance, if we had 4.2 newtons over here and we had 3 newtons acting in the opposite direction, the resultant would be just 1.0 newton when they're acting in the opposite direction. However, if they're acting in the same direction, So we can have 4 newtons acting this way, so it's going to be 4.0 newtons, and 3.0 newtons acting in the same direction. Then the resultant would be equal to 7.0 newtons. Of course, if they're orientated at an angle, you could also have any value in between. But in this case, the correct answer is C. Question 5. A projectile is fired in a horizontal direction at time t is equal to 0. Which graph correctly shows the horizontal component VH of the projectile? Well, if there's no air resistance, the horizontal component is going to be constant. So there is going to be constant velocity in the horizontal direction because there are no forces acting in the horizontal direction. So in this case, the correct answer is B, because that's the only graph which is not actually changing. Question 6. A ball initially at rest is struck by a hockey stick. It leaves the hockey stick at speed v. Which quantity together with the mass of the ball could be used to determine v? The time of the impact, the weight, the impulse, or the final momentum? Okay, well, now we know that this is essentially a conservation of momentum and Newton's second law problem, and we know that F is equal to delta P divided by delta T, and let's just put F delta T on this side of the equation. That's going to be equal to the change in momentum. Now this quantity over here on the left is your impulse, so we can just write this over here, that impulse is equal to the change in mass and velocity. So if we have the mass and if we have the velocity, we can work out the impulse, or in this case, if we have the impulse of the force and if we have the mass, we can work out the velocity v. So the correct answer is C. Okay, let's have a look at question 8, which is a little bit tougher. In fact, according to OCR's examiner's report, this was only accessible to about a quarter of the candidates. Well, let's have a go. First off, we have two resistors, 120 and 500 ohms, are connected in parallel. Percentage certainty in the value of each resistor is 10%. What is the correct value of the total resistance and the percentage uncertainty? Now, this is not a straightforward formula which is directly covered by the formulae for uncertainties that we looked at. We know that the total resistance is going to be given by 1 over 120 plus 1 over 500 raised to a power of -1, and if we put that into a scientific calculator, we are going to get about 97 ohms. Okay, well, how do we find the percentage uncertainty in that value? Now, what does the percentage uncertainty actually mean? The very fact that there is a 10% uncertainty in each of those cases means that we know that the maximum possible value for this resistance is actually going to be 120 plus 10%. So 120 plus 10%, which is 120 plus 12, which is 132 ohms. And also there's going to be a, so let's say that this is R1 max, and there's also going to be an R1 minimum value, which is going to be exactly the same. It's going to be 120 minus 10% of that, which is 120 minus 12, which is equal to 108 ohms. So this over here is the minimum value, this over here is the maximum value. We can follow exactly the same logic over here, and we can calculate 10% of 500, which is 50, which means that our R2 max value is going to be 550 ohms, and our R2 minimum value will be equal to 450 ohms. Now, what I'm going to do is just really calculate either the minimum or the maximum value, and then I'm going to compare it with the calculated value for our total. If they differ by 20%, the answer is going to be B. If they differ by 10%, the answer is going to be A. Well, let's do that. I'm going to calculate, let's say, the minimum value. So I'm going to say that our total, I'm going to say minimum, is going to be equal to 1 over, and now rather than 120, I'm going to use 108, like so, plus 1 over 450. I'm going to raise this to the power of -1. That into a scientific calculator, I'm going to get 87 ohms. Now the minimum value and the total seem to differ by 10 ohms, which in this case is equal to approximately 10% of the value. So 97 minus 87 is about equal to 10 ohms, and I'm just going to write this over here. 10 over 97 times 100 is approximately equal to 10%. So the answer will have to be A. Question 9, we have a potential divider circuit with a line-dependent resistor is shown. The intensity of the light incident on the LDR is reduced. What happens to the ammeter and what happens to the voltmeter? Now we need to remember this graph for the light intensity on an LDR. We can see that as the light intensity is reduced, the resistance increases. So we can say over here that the resistance increases. Now, because the resistance is increasing, that means that the current needs to be decreasing overall in the circuit. So that means that I must be going down. If the current decreases, that means that we know exactly what's happening to the potential difference across the voltmeter. Remember, this is a fixed resistor over here, and we know that V is equal to IR. We know that the current is decreasing, so the current is going down. R is a constant, because this is a fixed resistor, this doesn't change, which means that the potential difference has got to go down as well, because they are directly proportional according to Ohm's law, which means that the correct answer has got to be A. So question 10, the minimal potential difference across an LED before it conducts is 2.1 volts. The wavelength of light emitted by the LED is lambda. What is the correct expression for determining the Planck constant H? Well, in this case, we have a conversion of electrical energy. So we can just write this down. Electrical energy is being converted to photon energy. Our expression for electrical energy is E times V. This comes from this formula I'm going to write over here on the side, which is given in your formula booklet, that electrical energy or electrical work done is equal to Q times V. However, rather than Q the charge, I'm just being a little bit more specific and I'm using E the electron charge, EV. Now this is equal to the photon energy, which is equal to hc over lambda. H is Planck's constant, so all we need to do really is to rearrange for Planck's constant, and H will be equal to E times V multiplied by lambda divided by C, and we're given that the threshold voltage in this case is 2.1 volts, so H will be equal to 2.1 times E times lambda divided by C, which will lead us to the correct answer being D. Question 11. A cable is attached to an object of weight 30 newtons. If we're given the weight in newtons, let's just quickly convert that to mass. So that will be equal to 30 divided by 9.81, which is approximately equal to 3.1 kilograms. Now we have this object which has a mass of 3.1 kilograms, and this being pulled vertically upwards with an acceleration of 6 meters per second squared. What is the tension in the cable? Well, there are several forces. Well, there are two forces acting. We have the tension, which is acting upwards, and we also have the weight, which is acting downwards. Those two combined are going to give us the net force acting on the object, so we can just write that F net, or the overall force, is equal to the tension minus mg, which is acting in the opposite direction. Remember, the net force due to Newton's second law will be equal to m times a, which is should we just write this down actually? So this will be equal to ma, and this will be equal to T minus mg. Let's just rearrange for the tension. The tension will be equal to ma plus mg, which is equal to 3.1 times the acceleration which we're given here, which is equal to 6.0 plus 3.1, which is the mass, times 9.81. We're actually given the weight here, which is just 30. And overall, this is equal to 48 newtons, which means the correct answer has got to be D. Question 12. We have two filament lamps X and Y connected in parallel to a power supply. The power dissipated by lamp X is 24 watts, and this lamp over here dissipates 6 watts. The supply has an EMF of 12 volts and no internal resistance. What is the total current drawn from the supply by the lamps? Well, first of all, we need to consider that the PD will remain constant in this parallel circuit. So that means that if the EMF is 12 over here, then we are also going to have 12 volts across bulb X, and we're also going to have 12 volts across filament lamp Y. Now the power along here is going to equal to IV. So if the power is 24 across that bulb, that's going to be equal to I times 12. So that means that I is going to be equal to 24 divided by 12, which is just equal to 2 amps. Very similarly here, we can also use power is equal to I times V, which means that I will be equal to the power divided by the PD, which will then be equal to 6 divided by our PD, which is going to equal to 12, and that is going to be equal to 0.4 amps. Now, because this is a parallel circuit, we need to add the currents due to Kirchhoff's first law. So the overall current is going to be 2.5. So the correct answer is D. Please note that this means that 2.5 amps flow this way, and then 2 amps flow this way. Then we have half an amp going to both Y. Question 13. We have an object at the top of a ramp at point P, and then we know that the GP of that object over here is 100 joules. Then we release that and it travels down the ramp, and then at Q it has 60 joules. Okay, well, the kinetic energy of the object is 60 joules in particular, just down here. Well, calculate the average resistive force acting on the object as it travels down the ramp. We know that the change of energy, so change in energy, is going to equal to the work done. Now a change in energy in this case is equal to 40 joules, and the work done is force times our distance traveled in the direction of the force, and we know that this distance in this case is 5 meters, and the resistive force is going to act along this ramp. So our force will be equal to 40 divided by the distance, which is 5, which is going to give us 8.0 newtons. The correct answer is A. Question 14. The de Broglie wavelength of an electron after being accelerated through PD is lambda naught. The accelerating PD is now doubled. What is the new wavelength of the electron in terms of the original wavelength? Well, let's think about proportionality. There are two equations that we need to consider here. Now, first of all, the de Broglie wavelength is equal to h divided by the momentum, which is equal to h divided by the mass times the velocity of that electron. How do we know what the velocity of an electron is after it's being accelerated by a PD? Well, this is the good old EV is equal to a half mass times the velocity squared. Keep in mind here that this capital V here stands for potential difference, and this lowercase v stands for speed. And this over here is also speed or velocity, well, velocity in this case for the momentum. So I'm just going to label them just to avoid any confusion with what's capital and what's a lowercase. So this over here is the PD and this over here is the velocity. Okay, well, let's just rearrange for the velocity. So V is going to equal to 2 EV divided by m, and all of this is square rooted. All I've done is I've rearranged the EV is equal to a half mv squared for the velocity. Okay, well, how does the de Broglie wavelength depend on the velocity? We can see that this is actually proportional to the square root of the potential difference. In fact, I could even write this as h over m times the square root of 2ev divided by m. Now we know that if we double the accelerating potential, capital V over here, the new de Broglie wavelength will be proportional to that original value divided by the square root of 2, because everything else in the equation is exactly the same, and by proportionality the correct answer has got to be B. Question 15. The diagram shows an object submerged in water, and this object is stationary. Really important. Which statement is true about the upthrust acting on the object? It is 0. Well, that is definitely not true. If it was 0, the object will be falling under gravity. It is equal to the mass of the object That is not the case. That is not Archimedes' principle. It is equal to the weight of the object. Well, that has to be true because the object is essentially stationary, so it's going to have two forces which are equal and opposite. One is up thrust, the other one is the weight. 16. The intensity of a laser beam is 2 watts per meter squared. The cross-sectional area of the beam is 1 millimeter squared. It's going to be really important. What is the energy delivered by the laser beam in a time of 100 seconds? Well, remember, intensity is equal to the power transmitted divided by the cross-sectional area. So what I'm going to do is essentially just rearrange for the power. So if I know my power, I will know my energy as well. So power is equal to intensity times area, and this is going to be equal to 2.0 multiplied by the area, which is 1 millimeter squared. So that's going to be equal to 1.0 millimeters squared. Remember, the squared acts on the prefix as well, so this is actually equal to 2.0 times 1.0 millimeters, so that's going to be times 10 to the power of minus 3 squared, so it's going to be 10 to the power of minus 6, and yeah, overall this is equal to 2.0 times 10 to the power of minus 6 watts. This is our power. Now, because energy is equal to power multiplied by time, this will equal to 2.0 times 10 to the power of minus 6 in a time of 100 seconds. Oops, what's happened here? Let's zoom back in. So it's going to be times 100, which is going to give us 2.0 times 10 to the power of minus 4, giving us the correct answer, which is B. A block moves at a constant speed per amp. The diagram below shows all the forces acting on the block. Which force does no work on or against the object as it travels up the ramp? Well, remember, work done is equal to Fx cos theta, where theta is the angle between the direction of travel and the force. Now, only for the normal contact force, this angle is equal to 90. So in that case, this is equal to F times cos of 90 degrees, which is actually equal to 0. So that means the work done is equal to 0. The normal contact force does no work because it's perpendicular to the direction of motion. Question 18. What is the total resistance of the circuit between point X and point Y? Well, in this case, we know that those guys over here, those resistors, are in series, so the 20 and the 20, and the 30 and the 30 as well are also in series. However, everything between those 2 points is in parallel. So the equivalent for those two is going to be 40 ohms, and the equivalent for those two is going to be 60 ohms. So this is actually equivalent to a circuit which essentially we have a parallel branch between two resistors, one which is 40, another one which is 60. So the overall resistance is going to be equal to 1 over 40 plus 1 over 60 raised to a power of minus 1. If we put that into a calculator, we're going to get 24 ohms. And let's go over the last two questions of the paper. Question 19, what is a reasonable estimate for the momentum of a car traveling at 10 meters per second? So momentum is equal to mass times velocity. Let's assume that the mass of the car is 1,000 kilograms, very reasonable estimate, multiplied by 10, and this is going to give us 10 to the 4 kg ms to the power of -1, which corresponds to my answer being B. 20, easy last question, perfect, which is not an SI base unit. So the second is a base unit, the Kelvin is, the kilogram is, the coulomb, however, is not. So the correct answer is D. Okay, folks, so hopefully you found this video useful. If you have, please consider subscribing and giving this video a like. Thank you very much for watching. If there are any questions on the questions, do feel free to leave a comment down below, and thanks for watching.